Now we shall move to the numericals related to pitot static 2, pitot 2. Now I hope you all remember what pitot 2 was. Pitot 2 was a simple device which was used to measure velocity of flow, and the equation was velocity is equal to CV root 2GH, where H was the differential head. This is the differential head. Is the differential head, and it had three equations: P1 by rho g plus Z1 minus P2 by rho g by Z2, or x into Sg by S0 minus 1, or x into 1 minus S0 by SL. So the same equation P. Now let us see this problem. A pitot static tube placed in the center of a 300 mm pipeline has one orifice pointing upstream and the other perpendicular to it. I hope you remember what pitot tube was. It was an L-shaped hollow glass tube. So one end will be pointing to atmosphere and the other end will be in contact with the fluid. The mean velocity in the pipe is 0.8 of the central velocity. Find the discharge to the pipe if the pressure difference between two orifices is 60 mm of water. Take coefficient of pitot tube CV is equal to 0.98. So in the question, we have a pipe which is we have a pipe 300 mm diameter, and some fluid is flowing through the pipe. Some fluid is flowing through the pipe. Some fluid is flowing through the pipe, and a pitot static tube is attached to the pipe. So this is the case. The pitot static tube is placed in the center of a 300 mm pipe. One orifice is pointing upstream. This is pointing upstream, and one is perpendicular to it. The mean velocity of the pipe is 0.8 times the central velocity. That is something that requires our attention. So the pitot tube gives the velocity at the point of insertion. Here the pitot tube is inserted at this point. Okay, so it gives the velocity at this point. If the pitot tube was inserted like this, it would have given the velocity at this point. If the pitot tube was inserted at the top or near to the top surface, it would have given the velocity at this point. Now one thing that you need to understand is that if there is a pipe like this, and a fluid like this, a fluid like this, the velocities will not be constant. The fluid will be having least velocity over here and the maximum velocity at the center. Center will have maximum velocity, and here will be the minimum velocity. The reason being that the surface of the pipe is having some roughness, and because of that the flow will experience some resistance. As we move from the surface to interior, the frictional resistance or the surface roughness is getting reduced. The impact of that surface roughness is getting reduced, and thus the velocity will be maximum at the center and minimum at the surface. So considering this concept and the concept that we just said, the pitot tube gives velocity at the point of insertion. We have to consider this statement. The mean velocity in the pipe is 0.8 times central velocity. We know that Q is equal to area times velocity. Okay. Now this velocity is mean velocity. Now I have told you that the fluid will be having different velocities at different point. So while finding the discharge, we have to take the mean velocities of these different velocities. And here they have said that the mean velocity is 0.8 times central velocity. And the central velocity will be obtained from the equation CV root 2GH. Central velocity will be obtained from CV root 2GH. Okay, I hope that is clear. So the pitot tube gives the velocity at the point where the pitot tube is inserted. And the fluid will be having different velocities at different points. So while finding the discharge, we have to consider the mean velocity. And the pitot tube doesn't give mean velocity, but in fact it gives a central velocity. The point that I won't say central velocity, it gives the points velocity at the points where it is inserted. If the pitot tube is inserted at the center, it will give the central velocity. And you have to remember, central velocity and mean velocity will not be same, because at different points it will be having different velocities. So I hope the concept is clear. So the pitot tube gives the velocity at the point where it is inserted, and for finding the discharge, we need to find out the mean velocity. And the velocity given by pitot tube is not mean velocity, but it in fact is the velocity where it is inserted. So we have to convert the velocity given by the pitot tube to mean velocity, and then we have to find out the discharge. So let us start solving the problem. So central velocity equal to, now why they have called it as central velocity is basically because the pitot tube is inserted at the center. The velocity is equal to 0.98 times root 2 into G into, now the pressure difference, they have done the pressure difference or differential head. Pressure difference is same as differential head. Let me write that also. Pressure head difference is equivalent to differential head. These are all same things expressed in different terminologies. Differential head. So H will be equal to 60 by 1000 since it is in millimeters. Therefore central velocity will be equal to, central velocity, let me take my calculator. Will be equal to 1.063 meters per second. Mean velocity is equal to 0.8 times central velocity, that is 0.8 times 1.063, and discharge is equal to Q equal to area into velocity. Going to write mean in brackets, so that is equal to pi into d square, 300 by 1000 d square by 4. I got this from this value, pi d square by 4 times 0.8 into 1.063, that is equal to 0.06 meter cube per second. So this is how you have to solve. The only thing that you have to remember or understand is that this concept, mean velocity and central velocity, and the pressure difference between two orifices. This thing, pressure difference between two orifices, is nothing but differential head. So these are certain terms or terminologies that you will come across while solving the problems.